Hi, here I am. Haha. Late again. How are you? Oh, we have Ray here, Matthias, Christos is here, and Dave Darko, even though it doesn't show on the chat. Crazy Rupees. Matthias, Johnny is here, Maiko, Fruchtzwerg is here, Station 240, Quindor, Vodin, Patrick, hello. So, you just prepared your coffee? No, actually, I don't want to make like a 6-hour stream. It should be. We have. Our goals are not that high. We just want to assemble a piece and test if it's running, and I hope it does because we didn't change much. We just fixed our bugs and botches that we did with that one here, which we tested last time to run with stemma stuff or quicks or however you call it. And yeah, we just want to assemble the new one, and I hope I have all parts there because it was a little bit of a mystery. And then just check for the temperature of the DC to DC converter. I was a little bit worried with that version if it's when it's running from the power over Ethernet, the efficiency from 60 volts down to 3.3 volts is like in the low currents like 60% only, so you can imagine it gets quite hot. We measured even like 82 degrees. So this $2 K-probe thermometer isn't very precise, but precise enough to see like the ballpark of what we got here 5 hours later. Okay, let's not wait too long. I can maybe I switch the camera so we can do an unboxing on the other ones. Where is it? Here and there. Do I show my address? I don't think so. Okay. So let's cut it open. I got like only 5 boards from JLC this time. I tried this Eurolink shipping this time because usually when I do sponsored stuff with JLC, I tell them like they give me a coupon and then I can pay. Usually that happens within a day, but this time I just wanted to order it, not like communicate too much. It's a puzzle! They sent me a puzzle. That's sweet. We need to do this puzzle at some point. I'll put it over there. And these are the new boards. I think, did I use gold plating? Yes, I did. Let me cut it open. Oh yes, oh yeah, ooh. Let me show it. Here we go. This is the new design. And the labels are readable, woohoo! So, Fruchtzwerg, this is your label maker. And I figured that might be the right font size. I can check which one I used there, but I'm not sure anymore. And there is no cut. And there is no cut in the board anymore. So we actually, the power supply will dissipate a little bit heat to the right, to the LAN chip, because that one was only like not very hot. Raise the volume. What is with my volume? Volume up, but it says it's -10. Higher? What? What's with the volume? Wait. Can you? Oh, okay. Let me check for the volume here. What is my issue? I don't see. Okay, I just raised it to minus. It's like maybe the microphone, the laugh. I would put it somewhere here. I will blast your ears if I make it any louder. It seems to be low for mobile users and perfect on my TV. Oh, maybe it's like the highs are a little bit, I need an equalizer or something to make the highs more prominent, because the bass on my mobile fine, okay. Okay, I upped it a little bit, so it might be, I hope it doesn't cut off, but what did you miss, Christos? You missed only that the people didn't hear me. I was talking about all the achievements that we did. It's a little bit better. Oh, dudes. Okay, I crank it up on my amp, but it's your fault. It's your fault if it's, oh, now it's red. Oh, okay. Okay, it's minus 0 dB. Okay. Hello, Anshi. Hello, David. Okay. Perfect. Okay, guys, let's continue, or friends, let's say. Here, these are the new boards. I got only 5 because I don't need more than that. I don't have more parts for the devices, and they look nice. There is no copper pore here, so this is a. Let Christos explain why we don't have a copper pore on the top and the bottom layers anymore. That's not my fault. The labels are looking good. That's cool. We don't have labels on the bottom yet, but these ones, it looks a little bit, I don't think I want it like the inverted label style, because it looks a little bit like cramped now. I might just basically use basic letters here. I don't know. Okay, these are the parts. Now, this time I ordered from DigiKey. Now we are complete. I ordered from any supplier now. And we have a new flash IC here. There is like a bigger package flash, and I don't know which one it is. Yeah, that's one of the SPI flashes. And I got like 2 types of flashes this time to be sure one of those, or to test both of these. So I got a fallback for manufacturing if one is not shippable. So that's that. Then I bought some more of those because focus. Doesn't focus. Okay, here. I bought a bunch of those because we have now 2 footprints for the electrolytic ones. So I'm curious how that works. Now then I got some more resistors, I think. And here new part is resistor network. So 4 resistors, 10K in a row. That's all we got. So I will just start. I think we will do it by hand, everything. This time no paste. I didn't order a stencil because for one piece, I don't know, it doesn't really like make sense. Why by hand? Use stencil, come on. Plus 2 hours. No, it's not plus 2 hours because we have a mix of true hole and not true hole and what not. The last time it took us longer to do like stencil stuff and reworking because I'm not very good at this than doing it just by hand quickly. Plus 10 to solder bridge, yeah. Okay, so I will just grab, this is version, oh, actually it's version 2.1a for whatever reason. I think, oh, what did I change? Did I change anything important? I hope not. Okay, let's do the placement. I-bomb. Okay, I share the screen. Yoo! Maybe I will just quit this here. Okay, so let's get the parts in order. Let's start with the capacitors, I think. So I will just mark those. And let's do it like we did it before. Now I-bomb is also fixed. Maybe I can move that a little bit. Oh, I'm sharing too much. I'm sharing too much with YouTube here. Okay, let's do it like that. And we don't need only front. Hello, Adam. Static? Is there a static? What? Okay. So we got stream issues today. I turn on the fondue. Okay, so Fruchtzwerg fixed everything and those extensions. So we can, we can even zoom in. Wow, I didn't knew that is possible. Okay, let's source the parts, and where is my, this will be tedious again. So I put on my face while I'm looking for the parts. Okay. To the right one, this one here. What do you mean? Which set? Okay, whatever. Okay. It puts the board below all the components. Oh yeah, that, okay, yeah, I changed the view. Okay, let's get the parts. So we need, first of all, we need 22 nanofarads. This is like LCSC bag. Let me grab those. These are the resistors. Resistor. Same procedure as every year. This will be our show unit, so really we need to be careful here and do it properly. 22 nanofarads, I found it. Okay, so this is the first one. We have a smaller compartment for that? No. This is 22. Next one is 2.2. Don't have it yet. It's 4.7. If I ever find it here. Oh yeah, that's the LED. I have it here. It's a ton of different parts, so That might take a few seconds. That's the LEDs. 22 picofarads. MOSFET not needed. Two microfarads. You want to watch me doing it, don't you? I take the camera over here so you can watch me sorting the stuff. In the mess. Here you go. Will be maybe a little bit. Whee! Confusing. Luniception here. This is Luniception. Oh, the sound is bad? Really? I don't know. This is like terrible. What is going on? Oh, okay. Sorry, I just discovered that my Zoom capsule is trash again. It has like some noise on one of the channels. I turned it off now. Filtering noise. Yeah, that's like, I need the preamplification to be higher. Let me check that, if I can do a preamp. But then it's quite noisy. I don't want to be like... See, like minus 40 dB. It's like noise level. It's very annoying, can imagine. That's probably because of the t-shirt. Like looking in the mirror. Okay. Let me get all the parts now. 22 nanofarads, I saw that one here. 22 pico. 22 micro. Wait. 2.2, 100. No, that's not that. You want the noise back? Oh, I'm sorry. Wait a second, these are like different. Oh, yeah, that is one. I have different 22. This is another, no. What is this? I just discovered that here, that one. Is this a new part? I might not have that one here. Uh-oh. Uh-oh. That seems to be new. The old one has the tantalum there. Or am I wrong? No. Huh? Yes. Oh, there is a change. It says DNP. What's DNP? What does it mean? Noise protection. Oh, is this the... Oh, yeah, that's optional. Yes, that was the optional. Oh, okay. That was the optional for the grounds, for the two grounds. Yes. Okay. Thanks. Okay. So we have 2.2 microfarads. This is that one. 22 nanofarads. Okay, that's that one. Then we need 22 microfarads. That's this one here. And then we need 4.7 microhenries. Oh wait, that's not the, that's another one. 100 nanofarads. That one. Then we have 10 picofarads. What? That's like neglectable. Where did I have these picofarads? 10 picofarads. I have 22 picofarads. That's what kind of... Is the 10 picofarad something new, or did I have it before? Just bridge. Bridge or leave it open? Christos, is the 10 picofarads new? Because I have only like 22 picofarads. Uh-oh. Oh, yes. Oh, no. Oh, no. These might be new. Yeah, I don't have those, I think. Uh-oh. Let me check if I have some on stock here. 10 pico. Uh-oh, no. Oh, I might have, but only 0602. Let me check. Yeah. 0603. Here. Okay, I need to get those because I only have... I missed that one here, the part to order that, and I have only like my basic stock parts here. Oh. This is also DNP? Okay, sorry. Didn't see. It's like... But I can populate those. So I will leave them open right now. It doesn't say DNP. Okay, so 470 and 22 picofarads. This is that one. And that's all the caps, I think, yes. So let's do the caps. Okay. To the Batmobile. Oh, that's like super sized here. Is it? Sorry, I need to zoom in a little bit. Yeah, the whole PoE area. Yeah, maybe Christos can say something about this. So we needed to distribute a little bit more of heat there. So we changed few things and we fixed the bodges that we did before. Okay, here we are. It's like still a little bit blown out and our... Oh yeah, sharpness. Need to move this a little bit. Okay, this looks sharp. Sweet. Okay. Pink. Each component type we grab a little bit of fondue. What I need, maybe it needs a little bit of stirring here. It's heating up slowly. So the first one is 2.2. Oh, that's not right. The big ones are not too... Yeah, these are... Oh, these are different ones? No. Yeah, this is like a different type. Let me check. 4.7. I see a small error here. Let me share it. Okay, because these here, you can see these here, these are not 2.2. There might be a few parts mixed up, because I also have a few parts that are not used, like the 4.7 microfarads. Maybe Christos can clarify this. Cause let me check. Which version is this? It's 22. I think that's there is a wrong type somewhere mixed in. Let me show you, Christos. I got here. When I mark these, you can see the big ones are also marked, and I think the big ones were not 2.2. I have like 4.7 on the old one, so that's not the same type. The BOM file might be a little bit, or that's the wrong type picked there. Self-sealing potholes. Oh, you're talking about the heat wave. Yeah, that's like terrible, isn't it? Which big caps did I use there before? I have like yeah, okay, so that's not like it's the wrong part number here. Okay, can I use 4.7 microfarads there, the old ones that we got before? That's unfortunate. I don't have like the high voltage one in 2. What, didn't we use like the big ones before? We had, let me check that. I should have high voltage, the bigger ones somewhere. No, this was 2.22. Yeah. Okay, but is it a problem? Should I test it with smaller ones afterwards? I don't want to be it to be like the issue with the heating then. I'll use the 4.7 for now, and switch it later. Okay. Not sure if it's a good idea to solder the bigger parts first, but we have plenty of space here. Oh. Yeah, whatever. Whoops. On. Ah, that's a ground plane here. I should solder to the ground plane first. Or just remove it. Okay. Oh, okay. I really need a hot air station here. I will pre-solder the pads and then use hot air to reflow it. Otherwise, it seems to be a pain in the ass. Hot air, yeah, I will use hot air. Let me check where I need. I think this was one. No. Oops. Okay, I need to check if I missed any spot here. Quindo, if I don't practice, I will forget how to hand solder. It's a good practice. Oh, the camera isn't sharp for you. It's so far away, I don't really see it. So here is a sharper image for you. Oh, shaky hands today. Oops. Okay, I think that's that. Oh, no, did I miss the LUN I see here? Yeah, I missed one. So I see you got the right topics right now. Okay, 22 nanofarads. Uh-oh. Do I have a... Do I have this high voltage one? So these are two different types. This is also like two different types. 22 micro. Okay, 22 nanofarads. So this is the high voltage. And let me check. These here, is this the same type? It looks like a different footprint here. Okay, sorry. I turn off the screen capture. So I saw that on now. Oops, where is it? This one here. And now I'm on this one, but the footprint is not the right one. So let me check shortly with the schematic if this is another type. No, this should be also high voltage. C13 and C14. So there is a wrong footprint, I think. Am I right here? Yes. 13, 14. I closed the ones that I don't. I close everything that I don't need here. Okay. C4. C14. No, these are the high voltage ones, so this is the right one, but this one here is even bigger. So this footprint isn't right, or it's a different capacitor than we used before. Yeah, but this footprint is too small for the ones. That might need a small adjustment. Oops. I'm not sure if the manufacturer will like it this way here. Or is it like the original footprint here and all the other ones are just bigger? I can imagine that. But for me it looks like this is like an 06, 03 footprint. The heatsink works well. It still isn't melting on the 3.3 volts side. So we have actually a quite good heat dissipation there. Actually, it fits. It's quite tight. Okay. This was that one. All the high voltage caps supposed to be 06, 03. Okay, but the ones that I purchased, okay, I need to source a different part than for the 22 microfarads because I have 08, 05, so this is the wrong type even, so my fault here. Oh wait, this is the wrong cap. That's not 100 volts. Sorry. I need to get another one. This is like, it says 35 volts. That's not the right one. Okay, my mistake. Let me check if I can find it. Oh. Okay, let me switch this. This is the wrong capacitor. No, it's nanofarads. Actually, it is, and it is 0805. No, that is nanofarads here. I can prove it. Nanofarads, 100 volts. These are the ones that we have used. I need a different type then. Smaller footprint, okay. Move 1 to C4. A little bit confusion today. Let me check that. Or C4. Yeah, I have all placed already. This is microfarads. Let's do microfarads next. That is if I find those, because I can find it. Wait. (22 microfarads). This is the microfarads. This is also a different footprint. So these all changed. I will do the through hole parts at the end. What's the disaster count by now? Oh, it should be at 7. Or do you mean like the injury counter or counter last injury 7 days ago? Okay, let's do next. Oh wow, 100 nanofarads, that will be fun. No, I didn't heat my hand yet. But there is plenty of opportunity today. So now we need to do all the 100 nanofarad caps. We'll zoom out. I will just put it everywhere here. Some pre-tinning here. Here, and is it there? Yes. I will use the pre-tinning to mark where a capacitor goes. Okay, and then just place it everywhere. I think this is all. Okay. Let's clean the desk here and release a few caps. Let it snow, let it snow. Lip, 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 lip. In this case, the hot plate might also be interesting. More flux. Oh. Hui! And it's gone. More flux. Okay, I need more capacitors. This is the boring stream today, especially when I place the 100 nanofarad caps. I'm sorry if the image isn't centered or in focus, but basically there is not much to it. Just doing the same thing over and over again. Okay, I think I only need one more. No, two more. This is the wrong footprint. I don't know if that's meant to be a different one. It's running away. Okay. I think that should be all. Let me check if I missed anything. Nope. Okay, now let's do 10 picofarads, which are, okay, these are optional. We have 470. Ah. This is 470. And the last one is 22 picofarads. 22 pico. After that we need some fondue. And I hope I didn't burn it. Okay. And that was the last surface mount capacitor. Ah! Here we go. What did I miss? Try raclette? Yeah. I can do raclette once. Oh, I think the temperature and the consistency is right at the moment. It's quite hot though. I will turn it down a little bit. Some cheese. Are we done? Yeah, we are done with the surface mount capacitors. At least I think so. This was the least fun part. Yeah, Max, this is the new revision. It's final. Oh, we are 1.5 hours in already. That should be. I wanted it to be a short stream today. I better prepare the resistors now. Oh wow, that's like a ton of resistors. Let me show it. Oops. Okay, so I will just mark it placed. This is the inductor. I will mark it placed, even though it's not done yet. This is also placed. So let me grab the resistors now. Oh wow. Oh, this is a mess. Okay. Final, last, new, final, definitive. Short stream, less than 6 hours, yes. I need some energy here first. Let's go. So we want, no, 27 ohms. No, that's the 47. $27 next one. 49.9 ohms. This is this one here. Okay, I need to be sure that I got the right ones here. Okay, check. Next one. ICR 12.1K. $12.1K. 1.5K. Hmm. 1.5K. 43 point what not K. No. Maybe that's one of the new parts. Let me check that. $24.9. No, that's 24.9K is the next one. But this is not the... Hä? They gave me 2 packets or what? Silly. I'm missing only one resistor value right now. Oh, that might be down there. No. Nope. Oh, I have it. This is the one. Okay. So we got that one and that one. Now next one is 100K. This is this here. 95. I had the 95 here, I think. Yes. 95. 357. That's like a ton of resistors. 5.1. $10K. These are like the, oh yeah, that's the new ones. The resistor arrays. Looking forward to solder these. This here. I hope they fit. Okay. And that's all. Okay, we got all the parts and now let's do it again. Ta-da! Oh, one lost byte. Oh, this will be a huge chunk. Okay, I need a few more. I was thinking Sion was involved in I-bomb. Oh, that's so tasty. Delicious. This fondue was paid from the fondue fund. Thank you very much, everyone who donated recently. Johnny, I admit that the flower fund wasn't used yet, but for my excuse, Google pays out today, I think, or tomorrow. So the flower fund will be used soon. Fondue. me change that. The fondue. Oh no, that's not the run. Yeah. Oh shit. I dripped on the new puzzle. Now I licked this Chinese plastic. Okay. You don't need to see the face, you need only to see the parts. Let's do it. Oh wait, this is the wrong one. I almost saw that it in the wrong place. This is the one I need to do, and here. These two. Okay. Oops. What is this here? Where's this coming from? Or is it just a stray? I think that might be a stray cap. Uh-oh. Okay. Okay, whatever. Next one. $49 ohms. Like seven pieces. Oh, it's flipped. Okay, I admit maybe using a stencil would be faster at this point. But it's more fun. Okay. Next one. Will be 12.1. Next one is 1.5K. There are two 1.5s. Not enough flux here. Great. Next one is 43. It's also 2, 43. Oh wow. Oh, and it's gone. Okay, that one took off. Okay. Yeah. What Dave Darko says, that's the right way to solder. 24.9. Oh, that's our stray resistor. Now I'm confused which one is which. Next one is 100K. Ah. Wait. Uh-oh. I got the resistor here already. This is the, I had the wrong one somewhere. Oh yeah, that's the one. I need to move that one. This is funky. Yes, it would be easier, but I don't want to set it up. I need also to check right now if this is actually... Oh yeah. Oh yeah, I need to fix that. Let me share it. Where's the screen capture? Here. 100K or 43. I think I placed that one. Yeah. I need to remove one of those. So this one needs to be removed. DNP. Oh, 0 or 100K. We need 0 ohms here instead of 100K. 43. Did I populate that already? Ah, I'm terrible at this. Let me check what I populated already. Yeah. R43. It's R3. Oops. Before I do the same mistake like last time, I trusted the I-bomb, but we actually, this is R7 and, oh no, this is R7 DNP. This needs to go away, and this one needs to be 0 ohm. Yeah. Not 100K, okay. I must check if I got some 0 ohm resistors from DigiKey in 0402, no. But we can take the 0603. Yeah. It will be a little bit too large here. So this needs to go. This is the part for the fixed or not fixed version of this buck converter. Let me get some gunk here first. Okay, you can't see anything. I'm just replacing a resistor. Okay. Here. So this one is 0 ohms and this is gone. Oh wait, we can use 100K there as well. Wait. I think I would rather put there the 100K. Let me check that. Because this is feedback anyways, so it doesn't need to be, it can be 100K. Yeah. I will leave it 100K. It's better to test it with 100K. It's just a feedback. It should be alright. I don't know if this will get more noisy than with 0 ohms. It might. Oops. so this is the feedback. Okay, next 95.3. Okay. This is this one. Three, 5, 7. Oh, there is a small mishap. Okay. Next one. 5.1K. That's easy. That's USB. Okay. And the 10Ks. Yay. Here is one footprint. And here is one. Yeah, we need flux. Okay. Okay, there's one bridge. The bridge is gone. Nice. Okay. Cool. I like the resistor array. Okay, that That was every resistor so far. Now I deserve a little bit fondue. Ooh. So what are you talking about in the chat? Is it political? Do I get demonetized? It will collect my cheese. Ah! I dropped a piece of bread there. Oh, this will be like a monstrous... Oh no. I can... we should try to do like... the power circuit first. Ah, delicious. I think we have like 50% of the parts placed. Can we see that somewhere? Oops. This is the huge one, the buttons. This is the PNP. This should be the PNP. Oh, so good. Ow. It's the stream with the least text ever, I think. Not talking much, not many stories currently. Okay. Next thing, I would say I populate everything around there. Let me not use the eye bomb, I will use that one here. So SMH did the diodes. This is the button. Now, let me grab the diode. This is the J80. This is the diode. Then we have the LED. I think I had it here somewhere. No, this is the other thing. This is the LED. Then we need this PNP, which should be the generic one that we used before. So I will get one of these. Then we need this IC. Let me find that. Where is it? Wasn't that in a box? No. Okay. It should be here. No. Oh, I have plenty of stuff here. Oh yeah, I have this must be the voltage regulator, I think, yes. So I found a voltage regulator and an RP if I need it here. I will turn this off for a moment. Whew. This is the USB connector. Where are the chunky parts? Somewhere here should be the chunky parts. Nope. What is this? This is the Ethernet. Oh, I think it was in a box, wasn't it? Like a paper box. The power over Ethernet IC. Here. No, that's not the one. Where is the part? Somewhere buried here. Underneath all this stuff. Especially if not using a stencil, yes, that's longer. Let's take, especially if you are like so badly organized that you can't find your parts anymore. Oh yeah, here. That's the box, I think. No, that's not the box. The power IC should be in a ESD box. I have so much stuff on the table. Actually, it could have fallen down somewhere. Okay, you know what? I will just take it from another board. We have populated like 3 different boards with this IC. So basically, it doesn't really matter if I have like spare 3 here where we thought we broke it, but it's not broken, I think. I will take the old ones. We can test it and see if it works. Screen capture, face and microscope. In the fondue pot, yes. I'm curious where. Oh, here! I found it. Here are the ones I need. Okay, so let's grab that and let's start populating what we need here to get the high voltage first. So this is oh, let's heat it up first. I will move a few parts away. Ah, it's hard to get there. Okay. So these are the LEDs. It's unfortunately not pink because that's like this double LED. I could use single ones here, I think, next to each other. But for now I will go with the actual circuit that we want to produce here. Okay, we got everything except for the big ones here and the RJ. Okay, let's put on the connector. If I even have spare ones. Yeah, I'm searching again for my RJ45 connectors. Oh, come on. Yeah. Am I out of connectors? How many did I use? I can count here, I count 3 so far. So basically there should be 2 spares. Oh yeah, here they are. In this bag. Got them. Okay, this is important to solder completely so we get some heat dissipation. Okay. The new caps. So we got different capacitors now. Or let's try to connect it already. Oops. Let me get the cable here. So we can test if we get the power negotiation already. Oops. Wait, what? Huh? I don't see anything here. Is this... Give me the other cable here. Oh yeah. How can I show it? Okay, so I show it here. Can you see it? We get this short thingy. There's like this short blinking. Oh, I need to turn this off. Okay, can I need to extend this somehow. It's like... There are missing components where still yeah, I know the DC to DC converter is missing and the caps. So I just wanted to test if there is a negotiation between, or do you think that one here? Let me check. Should I populate more? What is missing right now that we really need to get blink sketches working? Brief sketch, okay. So screen capture. This is missing, but this is, what is this? Oh, that's an inductor. Okay, I will add these caps here and the DC to DC. We are populating the whole board. I just wanted to do it step by step because the last time that we populated the whole board, it didn't work and we had to remove parts again. And this time I wanted to make sure that each part is working, but we can basically go on with what we are doing here. And so let me get the DC to DC converter first. Okay. Blink sketch. Okay, I will leave the vent off right now because it's so noisy. Don't have much to do here. we'll populate the DC to DC converter, so we have a current draw. I hope it takes a substantial amount of time to reflow this part, so we are actually sure that our cooling is working properly here. Here we go. Okay. There is some excess here and here. I think we are fine otherwise. Okay. Now the big one. What is this? This is a stray resistor here again. This inductor is our heatsink for the for this DC to DC converter here. Wow, that stored some heat here. Okay. Now, oh, the caps. Ah, okay. I burnt myself again. Hear it on my finger. So, days since last accident, 0. Oh, this cap is too big. Uh-oh. Houston, we have a problem. I think I need smaller cap size here. Yeah. This is the wrong one. These don't fit really. Shoot. So I just picked some from DigiKey because I was not ordering on LCSC, and it seems that this part is not very like compatible. Fuck. Yeah, that's too tight. Can I move it? Need to move it a little bit. I will solder this one on and squeeze the other one in. I need a different type, a little bit smaller ones. Okay, that fits for now, but yeah, there is already like, I can see that one will be tight. There is one part missing. Okay, where's my... Okay. What is missing now? This part here. I have to find out what this is. Cue the Wilhelm scream. MMZ. Is this the one? MMZ. No, this is the ESD. This is the one, okay. The scutters look massive. Here the board is not very big. I will solder on this one here. Thankfully I didn't before, so we have a little bit of space there. Might be worth moving it a little bit down. Okay, that was that one. Shall we test it? Plugging it in? Or did I miss something? We have no load yet, but okay, there is I don't know if you can tell. We have power. Woo! Yay. Okay. So now the difficult part. So let me check what's next. Six pin is ESD protection. Oh yeah, there was like something. Wait a second. Okay, let me check what we need next. I would do USB maybe. USB next. Where's the screen capture. Okay, so what is this one here? What is this? Diode D4. What is this diode? Ooh. Part number CC5. I will find it. Nope. Measure buck output voltage first? Yeah, maybe. That would be a good idea. So let's measure it. Oh, I need some fresh air here. It's like get like really dizzy and I have cheesy air. Open. And okay, here. Let me check what we got. I won't show it, I will just check it and done. 3.46. Yeah, that's okay. There is no load whatsoever, so 3.4 is okay. Okay. Let me solder on the USB-C on here, the USB-C connector, and then we will continue with the diodes. I still don't know where this is the USB-C. Wait, this is USB-C power. Is this new? This doesn't look familiar to me right now. That might be a different ESD protection here. Oh. Christos, is this a new one here? This thingy. What is this one here? Diode. current voltage drop through the 100K feedback. Yeah, 100K might be a little bit on the high side here. I can switch to 0 ohms. We can test that. Reverse polarity protection. Is this new? Anyone knows if this... Okay, this is bidirectional. I will test 0 ohms instead of the 100K. But this is a fixed one. I don't know. Maybe it still needs a good feedback though. Where are my 0 ohm resistors here? Here. I will replace it quickly and measure again. Oh, quickly. Yeah, that's quite narrow there. I can maybe share it. Yeah, that's very narrow there with my... I'm not even sure how to change that right now. Wow. I could also just take 12.1K or something, or... Oh no. Okay. Okay. Let it cool down a little bit and then we check again. Maybe I use the opportunity to pre-tin here. No, I need to reflow that. That takes time to heat up, but I want it really to be well soldered there. Oh no. Okay. So this was the USB. Now let's check again if the 0 ohm gives us a better result. That's my multimeter. Okay, 3.32 volts. So good call on the 100K resistor. Now we should try to add this diode here, and then we can try USB as well. This is an easy one here. Pink LED version. I'm still trying to find the ESD. They move it over here. Oh. ESD, this is not. This is the one. Oh, that's a different package again. Okay, so this changed the package as well. Yeah, I will have to reorder some parts, I think, to test the ones that are actually used here. Uh-oh. It looks janky, but should work. Okay, let's test this one, if it's still working. No. So I'll cool it down a little bit, because we saw that this LED, if it's too hot, it will break everything. Yeah. Now it's working. And we should try USB. Okay, USB is powering, and let's measure the output. .29, that's okay. So power circuit is working. Now we can add the Raspberry Pi and the flash and whatnot. Let's go. Where are my buttons? Or should I? Oh! Ha! Oh, we got some donations again. The Flower Fund. That will be like, I'm getting jealous here, Johnny. I have to give flowers to my girlfriend, and then with a small card from Johnny. And Peter, thank you very much. True Pink LEDs funding. Yeah, but where do we find those? Where do we find true pink LEDs? I tried PoE. Oh, you maybe didn't see because it wasn't on camera. I tried PoE first. It was working like when it wasn't working when the diode was hot, but then after it was cooled down, it worked again. So this seems to work. The rubbish violet ones. What do I do with this reel of 4,000 rubbish violet ones? We should do a quest, the quest for true pink LEDs. Remind me to create a channel on Discord. And we will basically, we will do a shootout of pink LEDs, the pinkish pink LED. Oh, thanks, Equindor. Some more for pink LED flower fund. Sounds like a great video idea. You already have 4,000 LEDs. Great plan. Oh, did I speak with a Fab House? Yes, I did. Actually, I don't know. You maybe missed the last stream. Did I give an update? Basically, that was what I was doing like 2 weeks ago. And Vatterott would manufacture those. And they like without, because there was like problems sourcing the LAN IC, which will be available soon from a source that I don't want to disclose because someone will grab them from me. They gave me like a cost per unit tested production cost that is without any other costs is 15 euros around. So I'm not sure what would be like the selling price. It has to be at least 30 euros with taxes, I think, at least. That's a little bit on the high side. I don't want it to be like as expensive as a Raspberry Pi. But I do my best to lower the costs and get it manufactured, at least the first 500 pieces. And I will do like a funding campaign for that, I think. So I didn't decide on which platform yet, Kickstarter or Indiegogo or GroupGets. And then I will just do a short video introducing it, showing it. Seems more reasonable to me, Bitman. I think you could get more personally. Yes? Okay. Yeah, but I also want to make it affordable for like hobbyists. So not only like professional stuff, but also hobbyists. I will ask Vatterott what they think should be the selling price. There is also the risk that we have to switch to more expensive parts. Also the risk that we have like throw away half of the pieces. Quindor reported about his adventures. I think it was like a short video recently about how the production was not working well. And there are a few risks. So usually you would take like the 3 times the production cost for the selling price. You need some rest? Okay, Max. Rest well. So actually there's something going on. I was really exhausted from doing everything last week, so I didn't continue on that. I think we are on a good path, and I think I will when there's a campaign, I will try to start it in 10 days, like August, beginning of August, for a month, where I try to get the funds. I might try to get already the parts, but that's quite, the manufacturing of the first 500 pieces will be like 9,000 euros. So I don't want to like invest that much from my own pocket right now. So that's why I would go with a funding campaign. Short one, what are you doing for a living? This trashy YouTube channel and the main channel. So that's basically what I do, nothing else. If I would do more fun videos again, I would earn more right now. Currently, the development of this bot takes a lot of time and energy, so I wasn't able to do much else. Can you get payment terms with a fab house? I don't know. I wasn't able to negotiate something like that. You mean payment terms like they make it and sell it and give me like a cut? Is that what you meant? I feel you. I made batches of 1,000 plus. Yeah. Yeah. I want to. There is like currently one thing that's worrying me is the heat that's from the DC to DC converter. 82 degrees is on the high side, and we tested like OLEDs, running the OLED screen stuff last stream. So actually it didn't explode powering something like that from the power over Ethernet, but still it feels a little bit hot. So we changed the design, and I want no pro forma 60 days payment terms on initial invoice to assist in cash flow. Oh yeah, okay. Yeah. The one issue was also like purchasing the parts is quite difficult right now, and like the LAN IC, I would need to get a reel myself and send to them, because that's like it will be available, but not for long, and to secure that I would need to like get a reel, and that's like 800 euros for me already. Yeah, I see the problem that I might need to secure the parts that are uncommon when I decide on the final design, and then like run the funding campaign, whatnot, and do the rest there. So pay up front, the fab house up front. But let's finish the board right now. We are already almost 4 hours in. We should run a crowdfunding to assassinate those parts broker mafia. You know what? I have plenty of parts that are not available here. I could just sell those with like profit 100% and use these funds to to fund the other parts that I'm missing for the device here. Yeah, reselling might be worth. Also, yeah, there is a small difficulty right now. So my girlfriend and we are renting this place here, and I want to own something. And since I inherited a little bit, I wanted to use those funds to pay for a house. And I don't know if I have like a slack of like another few thousand on my bank account to use for experiments and not paying like for the house or something. So I think I might be cautious with my finances currently, because it might happen that we find a house within like 1 week and need to instantly like pay or something, because the house market is quite tense right now. So only 4 hours. So there is like another thing. So my private funds are like locked currently, and yeah, but I still have like a ton of parts here, and I think if I buy like the LAN ICs and this project doesn't work, or I don't produce it and I have a reel here, I could make a simple small board with this LAN IC as an extension or a shield for Raspberry Pi Pico or something, and sell this that without power over Ethernet and so on, and it would just work, and that could sell with profit. So, but that's like another 2 months or something. Be inventive. Don't risk your own money. Start campaign ASAP. Yeah, that's what I think. That's the best way to go. Get the ball rolling. Yeah, Aaron, you are the businessman. I'm just like a dude sitting in the basement and playing around. I need like a strong business partner to do the nasty stuff for me. But let's continue assembling the device. So I need the flash IC. Oh, what is this? Business talk, busy business talk. Yeah, months ahead. That's hard. I don't want like, I would not want to promise like something, a short delivery time for devices like these to people on crowdfunding, and then disappoint them with shortages and delivery problems like it's typical for Kickstarter. I want it to be like secured already up front, every part that I need to make it happen. And basically, okay, let's try this flash IC first. So I have 2 types of flashes. I think both are 16 megabit SPI, whatever. Because the old flash IC that I was using isn't can't be delivered anymore. So, oh, the package size is huge. It's just as big as the IC here. Is this even the right package? I hope so. Yeah, it looks like the right one. It's huge. So buttons, I wanted buttons. 3 months from ending. Okay. So before Christmas. Okay, where are the buttons? I need them buttons. Here are the buttons. Okay. Is this even the right way around? Yeah. Let me check. Where is the marking? It's the wrong way around, yeah. Here, like that. Looks like a different, this is like a different footprint. I think that might be even the, no, this IC is too big. Let me check the other one. Oh, interesting. Wait. Okay. So this is a completely different package here. Okay. So we got this package here and we got this one here. Look at that. Strange, isn't it? But it's nice and flat. Maybe we try this one first. The pins should be compatible. Let's see if it reflows there. I like this one here. I think both flash ICs were like 50 cents each from DigiKey. So actually even affordable for parts that are. I think these here are only available because of the huge package size here. Let's see if that works. Funny. Oh, it cooled down. I need to wait a little bit because we have like connection to the ground here. Okay. It seems to be aligned. Ah. Huge lump here. Okay, I think I have tin on each pad. I will just remove a little bit with some wick here. It's like full. Here is a... I'll remove the excess right now and then reflow again to get it straight. It should realign itself. I hope so, at least. It sits well. Okay, we need next, we need some buttons and the crystal. Oh, the button is a little bit hot. Oops. So, where's the crystal? This is 12 megahertz, okay. Okay. What we are missing is the LAN IC, the connector, and the voltage reference, and this diode, I don't know which. Oh yeah, and the magnetics, no, the protection thingy here. Where is the protection thingy? Need to find that. But we can test the USB power now, the microcontroller first. It should run right now. Good night, Stimple. Gute Nacht, Herr Stimpel. Is it Stimple? Stimpel? Stimpel? I don't know. Oh no, my fondue is drying. Okay, should I plug it in? Plug it in and see what happens. Okay. Magic smoke. Wheat. Oh, it works right away. Okay, let's see if we can program it. Let's see if we can program it. For the Germans, wie Stempel, nur mit I. Stempel. Okay. Okay, we can drop a sketch there. What kind of sketch do we want to drop there? Let me do like a quick Arduino. Yeah, we had this OLED demo. No, I have a sketch recent. Cheese meter. Yeah, this. Yeah, okay. I'll upload this one here. Oh, it doesn't. I need to preload a sketch before it starts. Oh no, this cheese meter is wrong. Let me just. I will just run and upload the demo. We need to populate these two ICs, the connector here, and then I don't know if it will upload a sketch. It might. DigiKey even offers to pre-program some of the ICs, so we could. I don't know if it's this flash IC or the other one, but actually we can use either of those if we make the pads long enough or something. We can. Oh, the sketch is compiling. It's too. Ooh. Yes, there is something going on. Okay, I think the serial monitor. Yeah, okay, so the flash seems to work because now it's a different behavior. It doesn't pop up as thumb drive anymore after we uploaded the first sketch. So let's finish it and use it. The first one without any bodges. Yay! Okay, let's microscope this one. Okay. So we need that one here, and we need a small IC. This. Oh yeah, I found it, and the LAN IC is here, I think. Yeah. Ah! Oh, this is working. Okay. I think this is fine now. Oops. Just add some solder here. Okay. Okay. Let's add this part here. Come on. Why is this so hard to tin this? somehow this gold plating seems to be a new brand of gold. Because I'm not sure why it's not sticking there. It's like, is there some kind of, yeah, I need to, okay, this is working. Now I will remove the remaining solder here again with some wick. This huge blob. Okay. That might have been the right amount of solder this time. Let me check the pins here. Here's some more flux needed. Okay. Okay, let's add the voltage reference as well. I think I saw it somewhere here. This might be, no, this is the N-channel MOSFET. No. Okay, I can't see the voltage reference anywhere here. So unfortunately, we won't be able to populate this part. Huh. It should be here. Where's the spare? Okay, I can find it. Oh, this is the... Oh, I can find the voltage reference, but it's not very important. Let's test it. No headers yet. Just let's test it like it is here. With, USB first. Focus. 2. It's done when the flux turns brown. Okay. I think we need this sensor with the sketch that is currently active. Wow, it's a little bit. Did it reset? Okay. And this is the chisometer then. Let me check if we can get an output from this sketch. Oh no, this is the OLED demo. Okay, so even better, so we can test the current draw. So the temperature with the current. Ah, oops, not break it. Okay, let me. I hope this is the right one. Oh, this is the OLED demo, that's not the right sketch. Ah, we had so many demos here. Which is all that. Okay, this is like, what's this part number here? It doesn't say. Oh, OLED feather wing. This is it. I2C. Okay, I will upload it. Oops. When it's compiled. Okay, so this is the OLED demo running. And now let's try running it from power over Ethernet. Where is the keyboard? Here. Of course, there will be still some testing to do. Now, magic smoke or not? Can we power it? Focus. Okay, it's powering. Okay, the OLED screen is running. I will measure the temperature right now. The Ethernet into the router, yes. Magic, no smoke. Okay, I'm curious now how hot this will be. Okay, I need some heat paste. Or you know what? We want to let it run for a few minutes before we actually measure the temperature, so we are sure that I can feel it already on the bottom side here. Oh wow, that's like warm already. That means that it's rooting very hot. Hey, Jan is da. You are in Leipzig. Are you visiting your sister? She was living in Leipzig, wasn't she? So Data Haki is a friend of mine. If you saw my video on self-driving, on the self-driving cars, where with the cart he was there. So I visited him in Zurich. Oh, I hope that isn't like a huge privacy breach right now. Jan, as you can see, now it's custom to have fondue on the stream here. Okay, it's a little bit cold right now, but we have always like cheese fondue here. Mmm. Mm. Oh, it's even cheesier and tastier now. I love it. Oh, it's warm to the touch, but not very hot here. I can touch it, but I think the IC will be a little bit hotter than this. I will put some heat paste. Oh, I hope it's not conductive. Uh-oh. Why is it so liquid? So witness me now. Ofenkäsegewürz. You want to try that? Okay. Oh wow, the temperature is jumping up like crazy. Okay, but it's not that bad. We have 63 degrees. Still rising, but it's better than 82 that we had before. Dip-dip-dip-dip. Isn't the probe technically cooling it? Look at the probe. It's like very, very thin connection. It's a K probe, so it's only like very, very thin steel wires. Okay, I like what I see now. I think this can be, with very slight changes, this can be manufactured now. I like it. 63 degrees. I won't be sued by someone who burns their fingers or something. Yeah, to the bottom of the chip, like here. We can test this area. And this is like, so the bottom is only 46. $64. Yeah. It's good enough for a first version. Can you get more heat transferred to the bottom? The problem with this IC is the IC doesn't have like a ground like pad or something. It's like very, very small. So what I thought would be I either replace the IC with a bigger one, since we have some real estate here, but yeah, that's like a redesign. Currently I like what I see here. It might be because I have so much paste. The paste is now probably also conducting the heat to the... I will put it in the ultrasonic cleaner to get rid of any stuff that shouldn't be there. And we see afterwards, it might be a little bit worse than now. but we fixed all the bodges that we had before, so we are in a good state here. Can you not make an exposed unique heatsink next to the ground pin? Yeah, that's an option. We can check it on the screen capture here. Woo. So the problem with the IC is, look at this. I will disable the silk screen. There is no pad. This IC is so small, there is no heat transfer. We have the heat transfer from this pad to the coil, so to the inductor. The inductor is also getting warm, so this is working. And then we have this here. This is like power, switching power, and this is our only thing here. This is ground. The ground pin isn't like the heat conducting one. It's the 3.3 volts here. This is the switching power and the input power. I think this is like, wait, no, this is, it's confusing. Yeah. So there is not much we can do with this one. And look at this, how many wires these are. See you, Bolly. I will be concluding the stream quite soon because it's basically we're... Oh, the paste didn't come off. I need to clean this with a Q-tip now. Oh. Okay, I need to turn the heating on. Hey, DevBomb. I will eat some cheese and we can discuss stuff. Cheese, yes. You want to see the joy? Yeah. I will just eat the remaining bread. There might be an option to place a surface mount heatsink. It just needs to be like standing upright on the board. I don't know if you can purchase like parts like that for a pick and place machine. I need to check if there are like solderable heat sinks. I might know a type of heatsink. I will just place pin headers next to it. I can show this IC is getting hot. This one here, the buck converter. And there is no way around it because there is no I found one buck converter that is a little bit more efficient than this one. We need to convert from 60 volts to 3.3 volts. The efficiency at low currents of this one here is 60%. So 40% of the current is converted into heat and in this small package. So there is no way around that this will get hot. I thought maybe there is another IC that I looked at which is available, which is a bigger package and has a ground pad. This ground pad would be way better to transfer the heat to the PCB. Yeah, I know, like exposing, but the problem here is there is only so much heat you can transport like with this direct connection here. The pads are so tiny, this is like hair thin. So there is only so much, this is like the bottleneck for the heat dissipation. We can open it up, okay, here, this is completely covered and this is all crowded, but we can expose like this here, we can expose a huge area here. That's not the problem. The problem is this area here is only 40 degrees while this one is 64 right now. and there is no heat transfer to this. So if you put this in a case, the case will always be 40 degrees. There is no heat difference, like temperature difference between the heat sink that will be here and the air around it. So the best place, okay, the IC is also too small to put a heatsink on top. I think the thermals are improved right now. I'm happy with the current state. It doesn't need to be perfect on the first version. As long I can touch it anytime without actually burning myself. Okay, I think it will still burn if I would touch it with with my eggplant or with my eyeball. That might still hurt. Water cool it. I will add a manual that it has to be dispensed in oil, mineral oil, 100% of the times while it's running. bitluni supports global warming. Yes. You can always run it from 5 volts. You don't need to use power over Ethernet. What the? Where is this coming from? I have like heat paste all over. Oh, it was. Oh, I used the wrong tissue here. I used tissue with. Okay. Okay, this board is called, has the power over Ethernet. It's not like not power or weakness over Ethernet, it's power over Ethernet. So it needs to heat a little bit. I will run it now and test what we can get out of it. Yeah, Quindor. What Johnny says. Okay, so back. Let's run it for a bit. Is it hot? You can't even touch it. It's like so. It's so hidden here. Ow! It's first degree burns tops. So No worries. No second-degree burns. Yeah, I'm wondering as well. This chip is like so tiny. It's probably meant for mobile phones or something. It's like super tiny one. Okay, let's measure the temperature. Can you see it? Here. I will touch it now. The contact area is too small. Let me. Some heat paste. Now we have no contact area with the surrounding. No 60 volt. Yeah. Yeah, super fast charging. I think there is something like that. So actually, power delivery and protocols like that, it might not be like 60 volts, but it could be. Designed to have a fan. I'm a fan of this IC, so or Christos is at least a fan of this IC. Puns intended. What's the spec? Okay, let me check the specs. I will let it run for a little bit. Burning skin. Ooh. Yeah, so we can't sell it to US customers because then I get sued. What? Let me grab the data sheet. What the? Okay, we have specs up to 150 degrees C. Do we have like some operation up to 150 degrees C? So it's plenty in spec. So we need a bigger chip to be able to burn the skin. Got it. So it's only 290 hours. Start being a problem. Oh, what? So what's the point if we need to switch to 2-ounce copper? So it will be like, that will double the cost of the PCB. What is the point of using this IC then? I think we are not like so highly space restricted that we can't use another IC. I don't want it to be hotter than like 90 degrees. Two-ounce copper immediately. Yeah, 105 degrees C. The caps are rated up to 115, I think. Ah. Are you winning? Yes, Dad, I'm winning. Oh, oh, okay. Now we are getting close to the temperature that I was talking about. This already feels hot. Like around 70 degrees. Yeah, random hex, you're right. That's the problem. To buy a Fleur. Fleur needs to sponsor me. I'm cheap now. So I said I'm cautious with my spendings currently. Flyback is step up, isn't it? We are stepping down from 60 to 3.3. At this point, I'm asking myself, what is so hard to do like proper step down? What's getting so hot there? Oh, it's down from 60, I think. The spec of power over Ethernet is like 60 volts up to, or 58, something like that. Usually PoE use transformers. Yeah. You know the meter isn't wrong. Aaron, I just wanted to test if you are still awake. It just turned off. So many experts. Oh yeah, it's 70 degrees. It's like 10 less than before. The version before was like 82. It's hot to the touch, even more on the bottom. Ow! I will make a crowdfunding campaign, and everyone that bakes one of these, we will do like a contest. Who stands the heat the longest? Ow! 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 What the heck did you tune? We are testing power over Ethernet with painful temperatures on the buck converter. I can check tomorrow, okay. Ow! 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 It's a little bit red, isn't it? Like, first degree burns. I'm sorry, but this can't be shipped to US. I will be sued to the ground if I ship this to the US. Just sell it on web. Yeah, I'm not a heat sink. I'm like, this is like not water, it's blood cooling. I'm circulating the blood away with the heat. Blisters, or it didn't happen. Look, it's red. Yeah, at least the circuit works now. Damn, it feels like this is far from be final. Oh. Ah. Or we sell it, since this is, look at this. This is USB dominant currently. So it's powered now from USB, and from USB it doesn't get hot. We sell the device as a Raspberry Pi with Ethernet capabilities, and don't sell it as a power over Ethernet. It's an undocumented feature. So everyone who uses it from the power over Ethernet, which is working, but it's getting hot. So this will be the Kickstarter pitch. The RPoE is a RP2040 microcontroller with Ethernet capabilities, and it also might or might not have power over Ethernet capabilities built in. Now with a free stemmer fan included. That's a good one. Use of power over Ethernet requires fan. No, the proper wording would be use of power over Ethernet may require a fan. Feels like more Indiegogo sort of thing. If using fan, the problem isn't the current. I can show it to you. The efficiency increases with the current. So basically the temperature stays the same. It will always burn like the same amount of power. I can, maybe there is an efficiency graph. I will share it. Let me check. But it's with all the buck converters, it's the same. If you get like at 30 volts input, it's no problem. You get like probably 80%. But if you are using like 60 volts input, the efficiency is only terrible. Let me show it here. Oh, wait. Here. Look, this is the current, output current, 60 volts in. Oh, we have even like at super low currents, we have 40% efficiency. And then at like 100 milliamps, we get 60%. That's terrible. And then we get 70% at 300 milliamps. That's terrible. I think I have one of the, oh yeah, that's the one that I was also looking at. I'm not sure if this is the right type, but if you take a look at this data sheet, that might be an alternative. Okay, you can see this is like 60 volts is the lower curve, and you get, oh wait, this is 8, this is 200 milliamps. Okay, yeah, so 100 milliamps, it could be the same. Maybe let's see if we can find better stats there. But we have a huge pad on the bottom which we can use to dissipate the heat. Huge pad. Let's use a fan. Here. Yeah, very detailed graph. Thank you for nothing. How can I... How far can I... So this is 100 milliamps. 50 milliamps. At 50 milliamps we have 50% efficiency. Maybe a little bit. No, this is 100. Yeah, around 40 milliamps. We get 50%. So this one is to the right. Which graph to the right? It doesn't let me scroll here. Yeah, but this is 3.3 volts. I want to add a 5 volt LDO. Yeah, I want to add an LDO because people will kill me if I deliver a microcontroller that doesn't supply 5 volts when it's powered from RP from power over Ethernet. It would only supply like USB power, and then if you power it from the Ethernet, it wouldn't supply any 5 volts. That's bad. So I rather want to switch to 5 volts and add an LDO for the 3.3 volts. So I can spread the losses between 5 volts and 3.3 volts. I can spread it like the heat, put it somewhere else on the other side of the board. And quadrocopter. Probably be cleaner too. Dual stage, yeah. That's what my plan is, to change it and switch maybe to a different one. And this IC even like supports 2 amps, so not that shabby. Not that shabby, is it? I must quickly hide this again, otherwise you will buy off all my parts that I found myself here. Yeah, now it's really like super cool. It doesn't heat up at all when I use USB. It's only power over Ethernet. Shit. Okay. I might want to do an alternative design for that. I have to check like 2 more things with that one. That's like a pre-final. It's a version A, and then we get a version B with the power that I will test. People wonder why I don't build PoE boards. Yeah, because it's terrible. It's a terrible idea. Don't do it. I will just, at this point, I just want to dump this project and like cut my losses. Anyone wants to license the design here? It's working. It's nice. We got some software. Like Elon Musk said, founding a company is like grinding your teeth on glass or something, chewing glass. How many versions do I have to make for this to be running? Or I do an Indiegogo campaign right now and get the funding for optimizing the design and releasing it in the optimized design. How about that? That could be an option. And run, yeah. I buy a house and run. Buy a house for the money instead. Johnny, did you bake the Pitchy printer? Yeah, it was the Peachy printer, like this laser on water SLA printer, where the dude built a house from the money and didn't ship the product. Man, that dude's reputation got wrecked. Yeah, I should do it like Brian does it. He made a board that's basically the 4 wires of USB 2 with 1 wire that is broken, and he bought his house from that money that he earned with that project. Brian, you designed a 4-wire connector with 1 wire broken. Oh, that's the best. Oh, where did you get this smiley from? I love it. Okay, cool. I'm happy that the board is working, the new design. The shield was connected too. Oh, wow. So it's actually 5 connections. Oh man, I'm envious. I'm just envious that I just overburden myself with projects that are actually complicated. And I have ideas of even better projects. More interesting than this one here. 5 connections, 1 broken. Top seller product. Okay, people, let's wrap it up. The Trinity is a little bit more involved. Yeah, that's true. But it's also like your 3rd version of that board, isn't it? The new one with the microcontroller. The first ones were just only shields. Highest selling product. Oh, I'm happy because there you can really make money from, can you? Oh, you mean the power blogger? Okay, people, let's wrap it up. I'm not sure what's next. I will try to set up maybe a campaign for this thing and do it like an honest trailer. I don't know. I probably won't be cleared by Indiegogo or jump ship on RPoE or not. Should I tell you? Should I tell you? I don't want to spoil anything because people will take my idea and run. So we had, okay, let's pitch my idea. In one word, no. In a world, no. Don't make revisions. What? Don't worry, make revisions. Okay, so you remember this thing here? I don't know if I ever. I was talking about that a few times. So ESP32 with like a mini computer with actual SD card, and this thing is already working. So it has everything on board. What I wanted to do, since the RP2040 has actually host capabilities, this IC, so this CH whatnot with the dual USB host capabilities, it's a pain in the ass to program. It's only like we can't use like an default USB stack with this because it only supports a C compiler, not a C++ compiler. So Aaron and I, we were programming this and we made an interface with the ESP32 which was working, and we could use human interface devices, but it was a really pain to program that. And my idea would be like to replace the CH component, which costs $1, with a $1 RP2040 that is used as a host, and maybe a second RP2040 for another host. Or because the hub ICs, if you check on hub ICs for USB, one hub IC costs like $3 or something currently. So you can put like two RP2040s as a USB host, and not using VGA but HDMI from either one of the RP2040s or a third one. So you get 2 or 3 RP2040s, ESP32, and that's it. Oh, the C3. No, the C3 doesn't have. The S3 has. C3 has USB integrated. Didn't I review one of those? We had one on stream. Or was it the C2? Did I get a C2 or the C3? Where is my stuff here? We had one here. I tested one. I think the yeah, it's the S3, and the S3 is more expensive than the C3. But actually, but then I would use the S3F, which has the flash included, because I need another flash for each of the RP2040s. Or I can somehow make all the RP2040s boot from one flash. This is the best. Oh, imagine all those crystals on the board hanging out. Yeah, we need another crystal. No, we have like, we only need like one crystal. They can chain and on one. Just use another RP2040 to manage all the flashes. Yeah, actually, that's the idea, to use also the RP2040 to program the ESP. 3.142 RP2040s on the board. On-board resilience cluster, now with extra cosmic ray safeguards, 3 RP2040 doing the same calculations better than NASA computer. Yeah. So that would be an idea, because the design is quite simple. The design is quite simple. We have everything already in place. We have a working USB-C. We have, okay, we don't have host. Oh wait, we can. Can we use just USB-C and add like 3 adapters? I have like super cool USB-A adapters for USB-C that are really like tiny. Just include them and we are good. No need to do like specific USB-A, or it would be cool to have USB-A, but okay. Please, nobody steal my idea. It's copyrighted. Right now, it's copyrighted. I will do it open source as soon as I designed it. It's super crazy. I would love it to see that actually working. Oh, and I need like the sound amplification that Peter did for me. Idea for a host human interface shield. Yeah, Brian. Yeah, boop. Nope. No, you didn't. You didn't copyright it. I was first. So am I fired yet? Not yet, Christos. I will license it for a small fee. Nope. RIP PoE. Okay, everyone, it was a blast today. The stream, we had a success. We have a working still running. RPoE is still running. The design is ready. Can be shipped. If we don't ship it, we make it open source, non-commercial, and add a small portion that says you can get a commercial license for the design for a small fee, like Brian would say. Oh, Johnny posted a video of his lab. Oh, I want to see that. Everyone, thanks for joining today. Can I add the music? Is this the music? Is it playing already? No, it's not playing. Where's... I can't hear any... Oh, wait. Here, okay, wait. Here. Ah, here we go. €1 fee with Muzak. Thanks everyone. We have here a working RPoE. I can't hear the music. That's terrible. I need to use like another time. Here, this is the working. Oh, we can disconnect it, run it from here, and run it from other things. And no bodges, I can touch it, I can actually touch it. There are no thin wires on top of it. Everything is great. Woo! Thanks Christos for the fixed version here. Well done. And I will continue this dreadful design process. Goodbye everyone, and now I have to find the button to turn it off. Bye.